Very few organizations can lay claim to a century of centralized research, collaborative problem-solving, and life-changing innovation. For 100 years, Corning has been making possibilities real through a combination of the brightest scientists, unparalleled expertise in glass and ceramics, and an unwavering commitment to research and development. Each invention has been a stepping stone for an ongoing tradition of exploration, scientific discovery, and breakthrough technology. In 1908, Alanson and Arthur Houghton hired a brilliant young chemist named Eugene Sullivan to establish one of the first industrial research laboratories in the United States. His first task, to develop a new glass composition for railroad lanterns, which were prone to breaking under strenuous conditions. Sullivan's borosilicate glass was break-resistant and tolerant of temperature changes, the perfect solution for enabling the country's transportation infrastructure. Sullivan's success led to an expanded lab and additional researchers who explored more uses for this revolutionary material. From their experiments, Pyrex was born, enabling new applications in the kitchen and in the laboratory. In the early 1920s, Corning scientists envisioned new possibilities for lighting, an industry Corning helped pioneer in 1879 with hand-blown glass envelopes for Thomas Edison's light bulbs. Bill Woods, a former glassblower, developed the ribbon machine, which ultimately made it possible to produce 2,000 bulbs per minute. This was Corning's first manufacturing process invention, and helped make electric light a feature of everyday life. By the late 1930s, Corning was producing a steady stream of innovations. Chemist Frank Hyde developed versatile silicones that combine the best features of plastic and glass. He also invented a revolutionary process for creating high-purity fused silica from hot vapor. This near-flawless glass became the foundation of numerous specialized technologies, including sophisticated telescope mirrors, space shuttle windows, and optical fiber. Corning scientists recognized the potential of a technology first unveiled by RCA in 1939. Using science from ophthalmics, William Armistead created a new glass formula for manufacturing television bulbs and cathode ray tubes. Engineer Jim Giffen then devised a process for mass-producing the components, making TVs affordable for almost everyone. Corning's next great invention came in 1957 when Donald Stuckey developed a new glass ceramics wonder material that made it possible for cookware to go from the freezer to the oven. Marketed to consumers as Corningware, the composition was so durable that it was also used by the U.S. military to make missile nose cones. By the 1960s, Corning scientists were testing 200 different glass compositions a week, and Corning needed a new facility to house its R&D initiatives. The same year that the Sullivan Park complex opened, a young scientist, George Beale, expanded the capabilities of Stuckey's glass ceramics composition, bringing further innovation into American kitchens. In a race against Bell Labs, Corning scientists Don Keck, Robert Maurer, and Peter Schultz began exploring the production of low-loss optical fiber. Their 1970 breakthrough paved the way for the commercialization of fiber optics and placed Corning at the cutting edge of the telecommunications industry. When the Clean Air Act of 1970 demanded a substantial reduction in automotive emissions, Corning once again supplied its problem-solving capabilities. Irv Lockman's revolutionary ceramic material and Rod Bagley's breakthrough extrusion process led to the catalytic converter, one of the most significant milestones in air pollution control. The combination of glass ceramics with catalytic materials also led Corning scientists to new frontiers in the laboratory. By bonding enzymes to glass, Corning scientists enabled new biotech applications and laid the foundation for future drug discovery tools. Corning's rare commitment to process research led to a revolutionary method for producing pristine flat glass. Today, Corning's fusion draw process produces the world's most advanced liquid crystal display glass, changing the way that people interact with information and entertainment. Throughout the 1980s and 1990s, Corning continued to invest aggressively in research and development, solving new problems and creating more possibilities. Sullivan Park scientists responded to the latest challenges in automotive emissions control with a glass ceramic filter for trapping diesel particulate. And Corning helped launch a communications revolution with a constant stream of optical fiber innovations that shattered the limits on transmitting and receiving information. By the time a new millennium dawned, Corning Science and Technology Center at Sullivan Park had grown to 1.5 million square feet. Now, in its second century of R&D, Corning continues to apply its materials and process expertise to deliver life-changing innovations, enabling cleaner air, more effective communication, and more efficient drug discovery. Eugene Sullivan created an environment where innovation would flourish. His successors have kept his legacy alive with new eras of discovery. That legacy lives on today at Corning, where scientists continue to invent the future and make possibilities real.